Okay, today we're going to do a review over addition and subtraction. And let's go ahead and look at our objective. Okay, our objective is 3.4a, and that's solve one-step problems involving addition and subtraction using strategies based on place value, properties of operation, and the relationship between addition and subtraction. And what we want to be able to do by the end of today's lesson is know when regrouping is required in addition and subtraction problems, and I can identify when to add and subtract in a word problem. And this is really just a review. Well, let's review from what we talked about earlier this year, but it's a review from second grade too. Addition and subtraction is not that much different in third grade. The only difference is when last year you probably primarily worked with two-digit addition and subtraction problems. This year we're going to work with three-digit subtraction and addition problems, and it's basically all the same rules. So this is y'all should do very well at this. So let's go over here and look at a couple computations. We're going to practice those, and then we're going to move on to some word problems. Okay, we have an addition computation we're going to work on here. It's 458 plus 497. And since there's a community property of addition, we could do it in any order. You could put the larger number on top or the smaller number on the top. It doesn't really matter. You're still going to get the same answer. We'll do it in the same order. It shows up right here. So 458 plus 497. And you notice when I draw my digits on my grid paper, all my digits stay within the lines there. So on the first problem, 8 plus, we're going to start in the ones place. So we'll do 8 plus 7, and 8 plus 7, just start with a bigger number and count up from the bigger number. So we'll start at 8 and go 9, 10, 11, 12, 13, 14, 15. So 8 plus 7 is 15. But I can't put 15 in the ones place. So I'm going to put the 5 in the ones place, and I'll carry the 10 from the 15 over to the tens place. So numbers go together well here. 9 and 1 go together real well. 9 and 1 make 10. And then add 5 to 10, that's 15. So I get 15 again. So 9 plus 5 plus 1 is 15. So I'll put the 5 in the tens place right there from the 15. Because actually it's not 15, it's 150. And I'll move the 1 over the hundreds place. And now in the hundreds place, 4 plus 4 is 8, plus 1 more is 9. So 458 plus 497 equals 955. Okay, we're going to do the subtraction problem right here. It's 600 minus 123. So whenever we do the number, do subtraction, we take the first number. That's going to be the number that goes on top. It's a larger number. So 600. And when I write my digits, I put them all inside the squares, minus 123. So typically this is what I'll see third graders at the beginning of the year do. They come right here and they say, okay, well, I'm going to take 0 from 3. So they say 3 right here. 0 from 2 is 2. And 1 from 6 is 5. And they'll say that's 600 minus 123 is 523. But that's not even really reasonable, because I know that 600 minus 100 will be 500. So taking away 123 could not be more than 500. It'd have to be 400 something. So that answer is just not reasonable. So we're going to go back and look and see what the third graders are doing incorrectly. So what you do is you're going to be aware that we're taking the bottom number away from the top number. And if the bottom number is larger than the top number, if there's more on the floor, you go next door. Okay, but in this problem, I have a 0 in the tens place too. So that means I have to go all the way to the hundreds place. And I'm going to take one of my hundreds, and that's going to leave me 5 hundreds. And if I move 100 to the tens place, that's 10 tens. And now I can take one of my tens, which will leave me 9 tens, and give me 10 ones. And now I can subtract. So 3 from 10 is 7. 2 from 9, we go count up 2, 3, 4, 5, 6, 7, 8, 9 is 7. And then 1 from 5 is 4, 477. This is the next thing I'll see third graders do. Look at this problem here again. So I'll write it out again. So 600 minus 123. Another thing I see third graders do is they're aware that I have to regroup right here because there's more on the floor, and you know they're going to have to go all the way over here, but they just arbitrarily go ahead. Okay, we say there's 5 here. They'll just go ahead and make that a 9 and that a 9 because we're regrouping. Okay, that is not correct because we didn't when we took 1 10 from here and we moved to the ones place, that'd be 10, and we're not regrouping again there, so that should not be a 9 right there. And I'm going to show you one other little trick here. This is something a student showed me. Okay, so they have, we'll do 600 minus 123. Okay, and this is what they did. They went ahead and subtracted 1 from the 600. So 600 minus 1 is 599. So they went ahead and subtracted 1. And then they went ahead and subtracted 123 from 599. And when you do that, there's no regrouping required. You just take 3 from 9, and 3 from 9 is 4, 5, 6, 7, 8, 9, which is 6. And then 2 from 9 is 2, 3, 4, 5, 6, 7, 8, 9 is 7. And then 1 from 5 is 4. And then what they did, since up here at the top, they subtracted 1 from 600 to get 599. You go down here and you just add 1, plus 1. And so 6 plus 1 is 7. And then just bring that 7 down and the 4. So that has made the regrouping a little bit easier. So 600 minus 123 is 477. And that's just a little trick way of doing it without having to regroup. Okay, let's go ahead and look at this word problem here. It says, Austin has 213 red paper clips, 508 blue paper clips, and 334 green paper clips. He makes a chain using all the red and blue paper clips. How many paper clips does Austin use to make the chain? So we're going to go ahead and use, I call it the KFC strategy. Some people call it KWC. I just like KFC because it sounds like Kentucky Fried Chicken and it's easy to remember. But the K stands for what do we know? Okay, in this problem, we're going to look at, I'm going to look at the second sentence. It says he makes a chain using all red and blue paper clips. So that's important right there, that the chain that he's making is all red and blue paper clips. So I'd write this over here in what we know. He's going to use red and blue paper clips. Blue. Okay, and so there are 213 red paper clips and 508 blue paper clips. So I'll do for red 213, and for blue is 508. And that's what we know in this problem. Something else probably good to do on these problems that we like the students to do. If there's information in there that's not important to us, they threw some extra information in there. The 334 green paper clips is not important because he didn't use any of the green paper clips. He just used red and blue paper clips. So that's what we know. And what are we trying to find out? So what we're trying to find out is, what's the question asking really? How many paper clips does Austin use to make the chain? So basically I'm going to take that question and turn it into a statement. So I will say he used blank paper clips to make the chain. Okay, period, right? Shouldn't capitalize my C there, but okay, to make the chain. Okay, and looking at special circumstances, the C stands for special circumstances, and that's kind of like some of our thinking. I mean, one of the special circumstances we already did, we lined out the 334 green paper clips because we didn't use them. But I always like to think about, what operation am I going to use to solve it? I do that over here in the C part, and I like to do this little addition, subtraction, multiplication, division thing, and it kind of a little thing that kind of helps me think through the problem and make a decision on what operation I'm going to use to solve it. So one thing I'm looking at, I only have two numbers that I'm using in the problem. I have the 213 red ones and 508 blue ones. So a lot of times when we have two numbers in math, that means there's really only one step. There's usually one thing we can do with those two numbers. So that's one thing I keep in mind. So it's probably a one-step problem. And another thing is the 213 is talking about paper clips. The 508 is talking about paper clips. They're the same thing. And the answer that I'm looking for is how many paper clips. So all those labels are all the same. It's all asking about paper clips. And a lot of times when all the labels are the same, that's kind of a little key that it's addition and subtraction. Whenever our labels are the same, a lot of times we add things that are alike together. So I'm going to go ahead and circle on my little chart here, addition and subtraction. So it's probably going to be addition and subtraction question. The next question I ask is, okay, I got 213 red ones, 508 blue ones. Okay, how many paper clips does he use to make the chain? The answer is going to be larger than 508 or 213. It's going to be larger. Okay, and there's two operations that we use to make things larger. And that's multiplication and addition. And you see this little thing I did right there? I circled that operation because it's going to make it a large. The answer is going to be larger. He used blank paper clips to make the chain. There's going to be a larger number. So you see this little thing, I end up circling addition twice. So chances are I'm going to use addition to solve this problem. So we'll go ahead and look at it. It's addition problem, and since there's a community property of addition, doesn't matter the order. I could go ahead, I could do the problem right here, right where I worked on it. But I like to do my work down here on the bottom. That way, if I'm making a model or anything, it gives me plenty of room to do my work. But I'm just going to do straight computation on this, and so I'm going to just do a straight addition problem. So that's 213 plus 508. And take your time, line up your place value. That's the biggest issue I see with third graders is messing up on alignment of the place value. If they're not careful, they might end up adding the tens place and ones place together or something like that. But that's just my little pet peeve. You see I somewhat got those in those grids, but if you're using grid paper, that's always a good strategy, or using lined paper and turn it sideways to help you line up your place value. But let's go ahead and look at this problem. 8 plus 3, I know 8 plus 2 is 10, so 8 plus 3 would be one more than that, would be 11. And I can't put 11 in the ones place, so I'm going to put the 1 from the 11 in the ones place and carry the 10 over the tens place. Okay, in the tens place I have 10 and 10, basically, or 1 plus 1 is 2. Which is 2 tens is 20, so I put a 2 in the tens place. And now in the hundreds place, I have 500 and 200, and 500 plus 200 is 700. So 213 plus 508 is 721. So that means he used 721 paper clips to make his chain. Okay, it's time to complete your independent practice again. Please complete the Schoology assignment you will find below this video link, and it's a blue puzzle piece, and it's going to be over problem solving with addition and subtraction. So just take your time and do your very best on it. And just like always, if you have any questions, please email your teacher or send them a message in Schoology if something's not working or you don't understand something about the lesson and you need some more help. Please email them or send them a message in Schoology. Go ahead, take your time, do your best on this assignment, and we'll talk to you later.